Morning students. Today we will start from temperature dependence of resistivity. As you know that what is resistivity? Then over a limited range of temperature, resistivity of a conductor is given by the formula rho T in subscript. This is resistivity at temperature T. Rho note is the initial resistivity 1 plus alpha delta T. Delta T is the temperature difference, then alpha is temperature coefficient of resistivity. Okay, from equation 1, this is implies that a graph of rho T means resistivity versus temperature would be a straight line. Remember this. The graph of resistivity versus temperature would be a straight line, but at a temperature lower than 0 degrees Celsius. Okay, because this is similar to y is equal to mx plus c, the equation of straight line, but straight line at a temperature lower than 0 degrees Celsius. Above 0 degrees Celsius, the graph deviates considerably from a straight line. You can see from this graph. In case of conductor, this graph is for conductor. For example, copper. Resistivity in 10 to the power minus 8 ohm meter and the temperature in Kelvin. Then you can see that the graph deviates from a straight line. Okay, some materials like nichrome is an alloy, shows a very weak dependence, means it is independent of resistivity with temperature. Means in case of alloy, for example nichrome, resistivity is independent of temperature. Okay, it shows very weak dependence. This is represented by this graph, resistivity in ohm, in micro ohm centimeter. Once again, resistivity in micro ohm centimeter and temperature in Kelvin. Okay. Now, in case of semiconductor, for example, silicon. Okay, the resistivity decreases with increase in temperature. This is represented by this graph. You can see that resistivity and temperature both are inversely proportional. If resistivity decreases, then temperature increases. Okay. Resistivity of a material is given by rho is equal to 1 upon sigma, where rho is resistivity and sigma is conductivity. You know that resistivity is reciprocal of conductivity. Okay, and this is equal to m upon n e square tau. Okay, how this is derived? Then the proof of this is, we know that I is equal to NEA VD. Okay, one relation you know that, and another, drift velocity Vd is equal to small e capital E upon m into tau. Okay, from equation 1 and 2 we get I is equal to NEA. NEA and put the value of VD. Small e capital E upon M into tau. Okay. Then I is equal to N E square capital E tau A upon M. Or I upon A, this A is comes in denominator, then I upon A is equal to N E square capital E tau upon M. But I upon A is equal to J, current density. Okay, so current density J is equal to N E square tau upon M into E. Okay, as you know that J is equal to sigma E. Then the value of sigma is this. Sigma is equal to N E square tau upon M. But we know that rho is equal to 1 upon sigma. So we get rho is equal to 1 upon N E square tau upon M. And finally, rho is equal to M upon N E square tau. Now, on this formula, we can explain the resistivity of conductor, insulator and semiconductor. Okay? We know rho is equal to M upon N E square tau. In this formula, rho is inversely proportional to N. Rho is inversely proportional to N. N is a number of free electrons. Okay? And tau is average time between collisions. When the electrons move in a conductor, then they collide. So tau is the average time between collisions. Okay? So in this formula, N and tau both are inversely proportional to rho. Okay? Now, with increase in temperature, average speed of electrons increases. When we increase the temperature, average speed increases. This decrease average time between collisions. So, tau decreases. When speed increases, the time between collisions decreases. Okay. Now, in case of conductors, means metals, as you know that metals or conductors have fixed free electrons, in number of free electrons. So, N remains same in case of conductor. Okay, but tau means average time decreases. Average time decreases with increase in temperature. Okay, and when tau decreases, then resistivity increases. This means when the temperature of a conductor increases, when the temperature of a conductor increases, resistivity also increases. Okay, once again, with the increase in temperature, resistivity of conductor increases. Okay, now for insulators and semiconductors, N means number of free electrons also increases with increase in temperature. N number of free electrons increases with increase in temperature. Okay, this increase in number of electrons more than compensates any decrease in tau. means the decrease in tau is compensates by increase in number of free electrons and with a more value. Okay, so when n increase in n, resistivity decreases. When n means number of electrons increases, resistivity decreases. Once again, in case of insulator and semiconductor, n increases with increase in temperature, so resistivity decreases. Okay, now a new topic, electrical energy. As you know that energy is the ability to do work. So in case of electrical energy, the energy required to maintain an electric current in an electric circuit. Once again, energy required to maintain an electric current in an electric circuit is called electrical energy or electric energy. Okay. For example, consider a current I. Consider a current I is flowing from A to B. Okay, in this device. Okay, then change in potential energy delta U is equal to final potential energy minus initial potential energy, or delta U is equal to delta Q into VB minus VA, because this is the potential difference and this is charge. So the product of potential difference and charge is equal to potential energy and change in potential energy. But as you know that the current flow from higher potential to lower, so we get negative value. Okay, then delta U is equal to minus V delta Q. Okay, now according to law of conservation of energy, kinetic energy plus potential energy is equal to 0, because before the flow of current total energy is 0. So kinetic energy plus potential, so delta K is equal to minus delta U, but delta U is minus V into delta Q. So delta K is equal to V into delta Q. This negative and this negative cancel out. Okay, now we know that I is equal to delta Q upon delta T. So delta Q is equal to, so delta K is equal to V into delta Q is equal to VI delta T. In place of delta Q, I into delta T. So the kinetic energy is equal to VI delta T, and this kinetic energy is equal to electrical energy. Okay.